Alrighty, so today we're going to be reviewing algebra, just some of the fundamental bits and pieces you've seen in previous years. If you want to keep watching, feel free to. If you want to skip ahead, it's not a bad idea either. We're going to talk about different definitions. We're going to talk about adding, subtracting like terms. We're going to talk about multiplying terms, dividing terms, expanding, factorizing, and yeah, just a few bits and pieces. Basically covering Year 8 algebra in a fairly quick sort of way. Year 9 algebra will come in a little bit later when we do some factorizing, expanding there. So looking first up at some definitions, what we're going to have, if we draw up ourselves just a bit of algebra to talk about, if we have 3x plus 2y, plus 2y plus 4. So firstly, what this is going to be, talking about, describing, this is an expression here. So the whole thing here, I would say, is an expression. And expressions are different to equations in that an equation has to have an equal sign. So if I came and wrote something like 4x plus 2 equals 6, that then would be an equation. Okay. Other bits and pieces you need to know, what a term is. So terms basically start and finish with the start of a add or subtract sign. So looking at my first expression here, I've got three terms there. My first term I've got is a 3x because I've started a plus sign. Down here again I start a plus sign. That means I've got another term in here. So I've got my three terms, 3x plus 2y and plus 4. By default, of course, my 3x here is positive 3x. So there are my three terms there. I took a longer example. Say I had 3x minus 2y plus 6 minus 4 plus x on 2. If I broke this up into terms, so looking for plus minus signs, the minus sign in here. So I've got a term in 3x. I've got a term here in minus 2y. I've got a term in 6. I've got a term in minus 4. And I've got a term in x over 2. So here, 1, 2, 3, 4, 5 terms for that expression there. Next definition I have is a coefficient. So a coefficient is the numerical part of a term. Normally, it's what you multiply the term by. So coefficients, for my expression here, my first term has a coefficient of 3. Okay, so a coefficient just fix that up, is the numerical part of the term. So first term here to 3, second term here my coefficient is minus 2. Here you don't really talk about coefficients when it's just a number by itself. We'll come back to that in a second. Here, if you like, this last term you come over 2 times x. So my coefficient here would be a half. Coefficient here is 4, coefficient here is 3, coefficient here is 2. Okay. My next definition I have is a constant term. So a constant, get a different color, a constant is basically just a numerical only term. Or, if you like, a term without any algebra. So right here, 3x is not a constant because of the x. Minus 2y is not a constant because of the y. But plus 6 here, that is a constant. Also, minus 4 is a constant. X on 2 is not a constant. Up here, 2 is a constant, plus 2 is a constant, 6 is a constant. And up here, 4 is a constant as well. they're my definitions for today. I mean, it might be worth talking about a pronumeral as well, or a variable, and that is just the algebraic part. So here the pronumeral is x, here the pronumeral is y, the pronumeral here is x, pronumeral here is y, pronumeral here is x as well. They're my definitions. So moving on from definitions, moving on from my definitions, I'm pulling up my menu, hang on, it's all moved around. Next, I'm going to look at adding and subtracting. So adding and subtracting. Adding and subtracting terms. So like you might have seen above, when you saw those terms, you might have thought we can actually combine these, particularly the constants. So if I give you an expression like 3x plus 2y minus x plus 4y plus, I don't know, 3y. What we can do here, we can simplify this. So looking at terms, I've got my terms here, 3x, 2y, minus x, 4y, and 3y. And my rule for adding and subtracting is I can only add and subtract like terms. So you can only add or subtract like terms. And what like terms are? Like terms here, these are terms with the same algebra. So looking at what I've got here, first term here, 3x. So 3x here, in terms of terms with the same algebra, x here, this is the same algebra. So this term here will combine with my first term. Looking through, there's no more terms with x there. So if I'm simplifying this, I've got 3x minus x. So you can think of that being like 3 sheep minus 1 sheep. That leaves you with 2 sheep left over. So you get an answer there of 2x for the x's. And then for the y's, my second term there, if you like, I've got plus 2y here. I've got plus 4y here and plus 3y here. Okay, you want to identify nice and clearly what the different terms are. So here I've identified the 3x terms with the circle, the x term there with the circle, and my y terms here underlined. They are slightly different color too. I know it's hard to tell. So going through, 2y and 4y is 6y, plus 3y will make plus 9y. Plus 9y. So my answer for this question is 2x plus 9y. Grabbing another question, let's pull that down. If I take, say, 3x plus 4 plus 5x minus 4. So again, working out where my terms are here. My terms 3x, 4, 5x, and minus 4. So my like terms here have 3x here and 5x here. They're going to go together to form 8x. So 3 and 5 is 8x. And then looking at my constants, so I've got plus 4, minus 4. If you do 4 minus 4, you get 0. So if you would like, you can write this as being 8x plus 0, just to identify for the marker that you've identified as 0, but your answer should be just 8x in the end there. Taking another example, if we had 2x squared plus 5x plus 6x squared plus x squared. Looking at this, again, break it down to terms. Always break it down to terms. We need terms, we need like terms. So terms 1, 2, 3, and 4 terms in there. Working out where my like terms are, I've got a 2x squared here, I've got an x squared in this term, I've got an x squared in this term as well. So those three will go together, 2x squared plus 6x squared, 2 plus 6 is 8, plus 1 here, if you like you can put a 1 in there. That's going to make 9x squared. And looking at my last term here, the 5x, nothing goes with the 5x, so I can leave it as being here, just plus 5x. It's really important to note here, it's a really common mistake that students say, oh, there's x there, they're like terms. That's not the case. X squared has 2 x's in it, x has just 1 x in it, so the algebra is different. So the answer for this one is certainly 9x squared plus 5x. You can't add them together, you can't do anything with that at this stage. So that's adding and subtracting, always looking for those like terms. Okay, same with subtracting, like you saw here, sometimes you'll get a bit of cancellation happening. Make sure you're firm and confident on your adding and subtracting positives and negatives will help you out quite a bit in getting that done. Sorry, just change screens. Sorry, just trying to get this recording right. All right. Next we're going to look at multiplying and dividing with terms. So multiplying and dividing, let's grab the heading down. And dividing. So multiplying and dividing, basically the rule is you're going straight through. I'm just going to do a bunch of examples and talk about them as we go. So if I take an example, if I have, say, 4x multiplied by 3y, what we're going to do, we're going to multiply the numbers together first. So 4 here, positive 4, times positive 3 is 12. And my algebra, I just combine that together, x, y. Similarly, if I had minus 3x multiplied by 2x cubed y, minus 3 by 2 is going to make minus 6. X by x cubed, there's 1x here, 3x is here, so 1x and 3 more x's is going to make 4x, so x to the power of 4. As a side note, you should recall your index laws that say x to the power of a times x to the power of b equals x to the power of a plus b. Or if you like, just for an example's sake as well, x cubed here is x by x by x. So if you have that, x cubed in there and multiply by x again, that does get you 4x's, so x to the power of 4. And lastly, don't forget to finish the question off. There's also a y in this question coming from my second expression there. Grabbing another one, if we have something like minus 6x times 1 on x, multiplying this out, top by top, bottom by bottom. So if you like, you can put this over 1 here. Top by top is going to get us minus 6x on x. And cancelling what I can cancel the x's off here. So that gets me an answer of just minus 6. Okay, if I'm dividing algebraic expressions, so dividing, well, the rule is we flip the second and multiply like what we would do with fractions. So if I have something like 3x cubed divided by, say, 9xy. I can just rewrite it, so I can just go for this is equal to 3x cubed divided by 9xy. Just put it in fraction form, and from there simplify. So the 3 and the 9 will cancel to get me a 3 on the bottom, 1 on top. The x's will cancel, 1x will go, so it becomes x squared. So answer-wise, 3 is cancelled, the x's become just x squared, and on the bottom, my denominator, I have 3y. Okay. An alternative to that, alternative method, not that it's vastly different, would be to take this here, flip it. So I could make 9xy over 1. So working wise, got 3x cubed multiplied by 1 on 9xy. And multiplying out top by top, bottom by bottom, becomes the same as what we've got here. Grab another example. If we have, say, 15xy divided by, let's go, 5x squared. Commonly, students get mistaken in terms of what ends up where. I would recommend pretty highly leave it as a fraction and then just cancel what you can. So typically what students do here, they see the x's cancelling, so the x's will cancel here. There's 1x on the bottom. They move that to the top. If there's more x's on the bottom at the start of the question, there's more x's on the bottom in the end of the question. The 15 and the 5 will cancel. That's 3 and that's 1 there. So I get 3. The x's have cancelled. Y. On the bottom, I've got 1, so that's going to cancel. And there's 1x left on the bottom. So my answer there is 3y over x. Okay, it's worth doing a bunch of examples on that dividing. The more you do, the better off you're going to be. Moving on, we're going to look at expanding and factorizing next. So expanding, some more space for expanding. So expanding in general is a process of getting rid of the brackets. So to eliminate the brackets, we're basically multiplying out. This is useful in algebra because sometimes it's helpful to look at things in different ways. And an expanded form might be helpful in telling me things that a non-expanded form might not. So a question is going to come to you, it's going to say something like 3x plus 2, and we're trying to expand that. What this means here is we're taking 3, we're actually multiplying it by x plus 2. So 3 multiplied by x plus 2, what does that all mean? Well, if we considered an example from earlier on in school, if you had 3 times 4, what you could do, you could write that up as being a rectangle, 3 by 4, and the area of that, well, you could put some crosses in, 1, 2, 3, and then 4 crosses across, 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, and you had 12. And you can think of the expanding here being the same. So the multiplying in here, we're going to have a 3 down one side, and the other side I'm going to get an x plus 2. So this here might be x, this here might be 2, this length across the bottom then is x in here, and a 2 in here. My areas then, well, this area here is 3 high, x wide, that's 3x. This last area here is 3 here, 2 there, it's going to make 6. So this gets me for an answer, 3x plus 6. You can think of it just taking what's out the front here, so the 3, multiplying it by both what's in brackets. So 3 by x is 3x, 3 by 2 is 6. I took another example, minus 4 outside of x plus 5. If I expand that, I'm doing minus 4. Don't forget the minus sign. by x. It makes minus 4x. And then minus 4 by 5 is going to get me minus 20. So minus 4x minus 20 is my expansion of that there. Sorry. Going a little bit more in the way of an example. If we have something like, let's go minus 3x multiplied by 5 minus 2x. If we expand that out, first bit out the front, multiplied by the 5 here, minus 3 by 5 is minus 15. Minus 15x it's going to be. Minus 3x by minus 2x, minus by minus is positive. 3 by 2 is going to be 6. X squared. Sometimes you'll see a question, it'll say expand and simplify, and you might get something like 4x plus 2 minus, and it might be 3 minus x. This question is fairly commonly wrong when students do it because they miss this minus here in the middle. So if you get that minus in the middle correct, generally fine, but normally the expansion of this last bit here is incorrect. So I'm just going to do it first set of brackets first. 4 by x is 4x, and 4 by 2 is 8. The second one here, I'm doing minus, which is the same as minus 1 by 3. That makes minus 3. Then minus 1 by minus x makes positive x. The minus here normally goes missing in the process somewhere. This comes out negative a lot of the time. Just do it as we've done there. Split it up into expand first, expand first. From here, it's just a like terms question. So my like terms here, I've got 4x. My next term is 8, next term is 3, last term is x. Like terms, 4x and x is going to get me 5x. Let's highlight these for us. So that's 5x. And then 8 minus 3 is going to be 5. Let's get my equal sign in here. So that is expanding. The last thing we have today is factorizing. We're almost done. So factorizing. It's basically the same as expanding, but backwards. So factorizing, the question's going to come looking something like this. It'll be 3x plus 9, and we're trying to factorize it. So we're trying to get some brackets in there. So before, when we expanded, we multiplied a number in. So multiply what was out the front in. Here, we're going to try and divide out the front. So what can I divide 3x and 9 by? I can divide them both by 3. So then 3 by what is 3x? Well, 3 by x is 3x, so that expands out to 3x. And then 3 by what is 9? Well, 3 by 3. I can check by expanding 3x, 3 by 3, 9, looking very good there. If I took an example of 2x minus 18, so again, what can I divide both 2x and 18 by? I can divide them both by 2. So 2 by what is 2x? Well, 2 by x is 2x. Then 2 by what is 18? It's going to be 9. And I need to make sure there's a minus in the middle. So I do get minus 18 in the end. If I had minus 5x minus 15x squared, here, what I can divide them both by, well, they're both negative, so the negative will come out the front, and that's convention. 5 and 15, I can pull a 5 out the front. can both be divided by 5. I can also pull an x out the front. They can both be divided by x. So minus 5x by what is going to get me minus 5x? Well, it's just 1. Then minus 5x multiplied by what is going to get me 15x squared? Well, it's going to be a 3 to get the 15 there. X by x is going to get me x squared. And then in terms of signs, that's negative there, that's negative there. A negative multiplied by a positive is going to get me the minus 15x squared in there. There's a bunch of ways you can probably look at it to get a little bit quicker. This is just a fairly standard way of factorizing for this sort of work. So one last example. If we are factorizing something like 3ay minus, let's say, 12a squared, what we're going to do here, 3 and 12 can both be divided by 3. A and a squared can both be divided by 1a. Y can't divide by y in this one. So 3a by what is 3ay? Well, it's going to be a y. 3a by, well, negative to get the negative 12, negative 4. Negative 4a will then get me my minus 12a squared there at the back. That's a quick review of algebra. So we've actually covered quite a bit of content. If you need to, I would recommend going back over past year's notes. Feel free to pause, go back over, do a bunch of examples to help you out. Okay, that's everything. Thanks for watching.